of the file and the actual input or this data. Okay, so it is also key and value. So key is the name of the file and the actual file is the input to mapper. Now mapper will process this. It is going to generate the intermediate results in the form of key and value. Intermediate key and value. That all the keys are shuffled by the shuffler task and they are reaching to the reducer, and input to the reducer is key and the list of values. So, so it is a list of values for the reducer. Now, reducer is going to operate on that list of values, and it is going to perform summation or aggregation or some calculation or average, and it is going to produce the output. And all the output is combined together to give the final output. Okay, so this way it is a process that you have to keep in mind always. MapReduce means always you have to remember this. Input to mapper is key and value. Output of mapper is intermediate keys and values. All intermediate keys and values are shuffled by the shuffler, by the framework, and they are reaching to the reducer. And input to reducer is key and list of values. And it is going to generate the output. All the output is combined together into a single output file. And if the file is big, it is also stored in the form of chunks. Okay, so this is about MapReduce. Now, so there are multiple algorithms of MapReduce. MapReduce is mostly it is suitable for this relational algebra operations. It is suitable for relational algebra operations. So this distributed file system, it will make sense only when the data is big and if it is rarely updated in the place. Okay, so we are using HDFS as a distributed file system for Hadoop. It makes sense only when the data is big. If you should go for HDFS if the data is big and it is rarely updated. And MapReduce also makes sense when the data when there is a data intensive computation. Okay, for example, if you are having Amazon as a website, and in the Amazon, if there are multiple things are happening, like online retail sales is happening extensively. So every second someone is buying something. So this for this retail, the multiple operations that you need to perform are sales for the search for the product. Okay, customer is going to search the product again and again. So many people are searching for the products at the same time. Okay, it is a virtual store, and virtual store means there is no limit of keeping the products to sell. Okay, if you're not having any online sale, if it is a normal shop, then the shopkeeper has a limitation of the space, and depending on the space only he can keep a limited number of products. But for the online retail sales, there is no such limit, so they can keep multiple products, any number of products. So searching of products is also their catalog is very big, and the people are continuously doing searching of products ka job, or they are recording their sales. They are doing the sales of they are purchasing, buying or selling, and they are the records are updated into the database. So in Amazon's website, continuously such calculations are happening. So this kind of MapReduce is not at all suitable for such kind of operations, because here your database is updated, and your data, if your data is big and it is distributed fashion, then updating of the database or searching from the database, it takes time. So still for such kind of operations, we don't go for big data kind of applications. But if Amazon wants to find out or some analytical query, such as it has to find out users with similar buying pattern, how many users are having similar kind of buying pattern, they want to find out similar users so that they can recommend the products to them. Okay, so for such kind of operations, we can use big data analytics, like finding users with similar buying patterns so that we can recommend them the products. Okay, so that's why for such analytical query, Amazon uses big data. Or Google first invented such kind of MapReduce is a product by Google. They made it open source after some days. So why Google wanted this MapReduce? Because they wanted to do the page ranking. They wanted to calculate the page rank for the query entered by the user, and they came up with some page rank algorithm. And in that page rank algorithm, there is matrix and vector multiplication is to be used. And in case of Google, the size of the matrix is huge, and the number of elements in the vector are also huge number of elements. Because if you have to perform a matrix vector multiplication for the matrix of size of 100 elements or 100 rows, then though you can manage with a single machine. But if your size of matrix is huge, it's a billions of like tens of billions of elements are there in the matrix, then they cannot fit into the memory. Then they cannot fit into the memory, and then your answer or the resultant matrix is also big, which cannot fit into the memory. So Google came up with this MapReduce technique, and this example is actually a proper example for parallel computation and calculation of the results in the parallel way. So that's why this particular problem is very important. It is asked in almost alternate exams. Matrix vector multiplication. Vector multiplication is very simple. Multiplication is little difficult to understand. So today I am going to teach you first about matrix vector multiplication. And then if the time permits, then we will go for matrix multiplication. Okay, so you understood why this MapReduce and where it is suitable. MapReduce is suitable for big data kind of operations with analytical queries. And Google wanted to do matrix vector multiplication for the calculation of page rank. So that's why they came up with such kind of multiplication algorithm. And this algorithm nicely fits into the MapReduce style. Okay, because the size of the matrix is huge, which cannot fit into the memory. Okay, now what happens in case of matrix multiplication? You have done it for so many times. Okay, each and every language when you study, you have done matrix multiplication. So suppose I am having a matrix A. Okay, now you listen carefully. We are talking about matrix logic about this multiplication. Suppose you have the matrix A, which is m by n matrix, means m number of rows are there and n number of columns are there. Okay, so the element of matrix A can be represented as aij. Okay, so so I'm going to use the variables I and j, where my I is going to indicate row for the matrix and j is going to I'm going to use the j to indicate the column. Okay, now normally when you do this multiplication, you have to use for loops. Okay, now in case of vector, your vector is of the size of n. Okay, if you want to perform matrix vector multiplication, if your size of matrix is m by n, your vector should be of the size of n. Okay, so the length of the vector is n. Then only this multiplication is possible. Okay, because this n and this n should be same. Then only the multiplication is possible. So now assume I'm having a matrix A, m by n ka matrix. My element is aij, where my I is going to indicate the current row and j is going to indicate the current column, and the vector is of the size of n. Okay. Now suppose the vector product is a vector b. When you do the multiplication of matrix vector, you get the answer as vector. So suppose my answer vector is b, it will have m number of elements. It will have m number of elements. So I need to perform this particular operation of calculation of the element bi for m times. So my variable I is going to vary from 1 to m or 0 to m minus 1. Okay, we'll see this again in the next slide. Right now, you just try to understand whatever is possible. And now, for calculation of BI, will need something like a multiplication of aij into vj for n number of times. Okay, so like suppose we are doing this for in the sequential manner. What we do is that we write two for loops. One for loop is for m number of times for I is equal to 1 to m, and another for loop j is equal to 1 to n for n number of times. So we use two for loops, and we calculate the terms in the sequence. We calculate first b1, then b2, then b3, and then bn. But we can calculate them parallelly. All the elements can be calculated parallelly. There is no need to go in the sequence. If we have multiple machines, we can execute or we can find out all the terms at the same time. Okay. So now how this matrix is to be stored? Like whenever in case of this big data, this matrix element aij is stored as I comma j comma aij. Okay. So So is it efficient? When such kind of like I want to store the element aij of my matrix, like my element a11 is equal to suppose 5. I want to store 5, and it is the first row, first column. So it is stored as 1 comma 1 comma 5. So can anyone suggest me like when why to do this way, or what is the advantage of doing or storing this element? Okay, I'm my question is that I'm storing the number 5, which is my array element 1. So my I is equal to 1, j is equal to 1, and the element is 5. And in case of big data, that element is stored as 1 comma 1 comma 5. So why do we store it like this? You can write down in chat your answer, or you can unmute and tell me the answer. See, suppose in case of Google or PageRank algorithms, your matrix is a sparse matrix. Sparse matrix means most of the elements are not having any value. Only few elements are present into the matrix. So, so if you are using a conventional method to store the matrix, it is not. It is going to take more space. So, in case of sparse matrix and in case of distributed storage of the elements, we need to store the elements as I comma j comma aij, where I is the row number, j is column number, and aij is the actual element. So I'm going to store the element as 1 comma 1 comma 5, and the vector element is stored as a pair, where j is the location, and v is the actual, vj is the actual vector. Okay, that we'll see this again in the another slide. Okay. So now in this matrix vector multiplication, see, this is the example of matrix vector multiplication. In this example, I'm having a matrix A. I'm having a matrix A, 3 by 2 ka matrix, where there are 3 rows and 2 columns. Okay, and these are the elements 1, 2, 3, 4, 5, 6. So my I variable is started from 1 to n, and j will be incremented in this manner. Okay, 1 to this is m by n ka matrix, so 1 to n, and this is 1 to m. And this is my vector, it is 2 by 1 ka vector, and it is having two elements 8 and 9. And when I have to do this matrix multiplication, what I do is that uh, I uh, I will take the first row. I'll take the first row and this first column, and then I'm going to do the multiplication. So 1 is multiplied with 8 and 2 is multiplied with 9, and that is my answer for the element bi. Here I is equal to 1. This is the first row. For the first row, how I calculate the first element for my B matrix is that first row and the first column of the vector. So this way I'm going to get. So like this, the process is repeated for m number of rows. Okay, so I think this you know. Now when my elements are stored, the element is aij and the vector is v. So you need to remember this, and that's why I'm keeping this same information on the screen. That my element b1 is equal to j is equal to 1 to n. So j is equal to 1 to n for 2 times. Aij means the first element, because I is equal to 1, j is equal to 1. So first element, that is 1 into uh, v1, that is equal to 1 into 8 plus, now j is incremented, j is equal to 2, so it is a12, that is equal to 2 into v2, that is equal to 9. So this calculation is represented with the help of this formula, that b1 is equal to j is from 1 to n number of uh, n number of times aij into vj. Okay, so I think this is understood. If you have not understood, just read it properly, you will understand this. Otherwise, you remember right now for understanding of the lecture that this first row and first column, and I'm increment multiplying 1 into 8 plus 2 into 9. So finally I should get this answer when I'm doing the parallel computation. Okay, so this matrix vector multiplication is possible when this number of this 2 and this 2 is same. That's why it is possible. And we are getting 3 by 1 ka vector. Okay, so I have done this observation of matrix vector multiplication. Now I have to write the map function. This is a map function. Uh, but before reading this or understanding this map function, pseudo code, we'll see like what is it. Okay, what it is saying is that for every element, now this each and every element is given to a mapper. So mapper is going to get this element in the form of I comma j comma aij. So my first element is 1 comma 1 comma 1. Second okay, so what mapper is going to do is that this first mapper, it is getting 1 comma 1 comma a11, that is equal to 1. Okay, so it is getting this triplet, means the combination of three elements, 1 comma 1 comma 1. What is the mapper's output is that mapper is going to read this and it is going to produce this output as I comma aij into vj. Okay, so j is equal to 1. So it will fetch the value of vj, that is equal to v1, and v1 is 8. So it will fetch the value of v1 from somewhere, or and it will get the value 8. And this mapper is going to create a pair of elements, that is the intermediate keys and value, where the key is I and value is 1 into 8. Okay, so it is getting I1 and the value 1 into 8. So this first term it is getting, it is intermediate value. So like this different mappers will get, like the second element is first row and second column. So first row and second column may you are getting the element as a12, that is equal to 2. So this mapper will receive this term of matrix element, and it is the job of mapper is to just extract the output. The output is I comma a12 into vj. So it will extract this I means 1, and it will multiply this 2 with v2, because j is 2 and v2 is 9. So it is going to extract 2 into 9. Okay, then maybe the third term is with the third mapper. This third mapper will get the index as 2 comma 1. So the value is the element is 3. So it will create the output as I comma aij into vj. So it will create 2 comma 3 into 8. So now the third mapper has calculated the intermediate code 3 into 8 in the form of key and value, where the key is 2 and value is 3 into 8. So another mapper will do the same thing, like 2 into a to 2 ke liye. So like this, suppose I am saying that there are 6 mappers. Then all 6 mappers will get the input as I comma j comma aij, and it is going to produce the intermediate keys and values as I comma aij into vj, which is the term of a partial term or partial calculation. Okay. So see here the code for the mapper. It is the mapper's output is the intermediate key value pair. So this is the mapper's output. And see the code here, that mapper is going to take the key and value, and it is going to produce for every I comma j comma key and value here is the name of the file and the actual this term. Okay, this array element is the value and key is the name of the array. So it is going to receive this and it is going to produce I comma so for every I comma j comma aij in the value. So in this value it is having this I comma j comma aij. For every aij in this value, so if it is receiving two elements, this for loop will be executed for 2 times. Then one mapper is getting 2 keys, 2 values. So like this it may happen depending on your splitting of the data or chunks created. So for every element that it has received in the value, it is going to emit I comma aij vj. That is I comma aij vj. That is the intermediate key value pair. Okay. So have you understood? Any doubt in this? Stella, can
No, ma'am.
you
No,
understand
ma'am.
this, because this is little complicated. Your array element is stored as I comma j comma aij, And now the job of mapper is to extract I comma aij into vj, and it may receive vj from somewhere, or it is pushed to that machine, that vj. So we don't know what is happening. It may ask for vj, so it is asking only for the one value from the network, and it will get the value, and it will do the calculation, and it will give this output. Okay, so these are the intermediate key value pair, which is the partial calculation. Okay, so
Yes,
this is
ma'am.
done. Okay, now shuffling. The next task is shuffling, which is done by the framework. So shuffler will now what shuffle will do? It is done by the Hadoop framework, and it will shuffle the same keys at one reducer. So this is your key. The first column is the key. All the keys are shuffled in such a way that they are going to the same reducer. Okay, this is always happening in shuffling. All the same keys are going to the same node. So here uh, the output of the shuffler is key and the list of values. Okay, key and list of values from mappers. Okay, so it will shuffle, and now both the keys are reaching to a particular reducer. So suppose, so here it is in this form, that key is equal to 1 and a list of values. So there are two values in the list, 1 into 8 and 2 into 9. Both the values are reaching to the reducer, and now this is the reducer. This reducer's job is to calculate the summation of all the values in the list. So in the list there are two values. This reducer's job is to perform the addition of these two elements. So it will do the addition, that 8 plus 18, and it will keep the answer here. So the output of this reducer is the first element ka answer is 1 into 8 plus 2 into 9, which is the answer for this vector. Okay, so like this here, the second in the shuffling, the key is 2. So all the keys which are having the value as 2, they are shuffled and they are reaching to one particular reducer. uh, and the output of the shuffler is this intermediate output of the shuffler is this key and the list of value, that is acting as input to the reducer, maybe the second reducer, and it is going to do the addition. So it will say that the second element is 3 into 8 plus 4 into 9. Okay, now this key 3 is shuffled by the shuffler, and it is reaching to a particular reducer uh, as a key and list of values. This is acting as input to this reducer, and the reducer's output is 3 comma 5 into 8 plus 6 into 9. Okay, so now this three, all this, if there are three reducers, all these three operations are done in parallel, and all the three terms are calculated for the vector. If you see here, this vector b is stored in the form of any element bj is stored as uh, or if the element b1, if you want to see the b1 element, b1 is stored as 1 comma 1 into 8 plus 2 into 9. So here 1 comma 1 into 8 plus 2 comma 9 is the element b1. This is the b2 element, and this is b3 element. So all the elements of vector are, as I shown you in the previous slide, the elements of vector are stored as the number of the element, number of row, and the actual value. Okay, this way it will get stored. Now see the pseudocode for the reduce. So if you understand this particular flow, then it is very easy to write the pseudocode. And in the exam, they ask you to write the pseudocode. Okay. In the from last year, they are giving more important to matrix vector multiplication than matrix multiplication. Matrix multiplication is very complicated, but they are many of the examiners are now concentrating on this particular, like it is a favorite question of the examiners or who set the paper setters. Okay, so in the reducer, if you see, it is very easy to write once you understand this. This reduce function is taking input as key and a list of value. Okay, so it is taking this input as a key one and the list of values. So if you assume this data is going as a parameter values here, then it's very easy to write this code. So you assume that you have to get this result. So the value of the result is assumed as it is equal to 0 initially. Then use a for loop for a value in the values. So value is the iterator and values is the list. So this iterator is going through all the values of the list, and it is taking this value, it is taking the first value, adding it to result. Then the second value, adding it to result. So there are only two values in this case. So it will take the first value, add it to result, and then it will take the second value, it will add it to result. So in the result, you will get 8 plus 18, and for the first key, and then it will emit key and the result. Okay, so this is a very simple. Once you understand this, um, it's very easy to know that this is happening in mapper and reducer jobs. Okay, so remember mappers output, mappers input is um, mappers input is the matrix element as a value, and the name of the matrix or name of the file as a key. So the element matrix element is the value, and then for looking at the value, because ij is specified, the job of mapper is to emit I and some calculation. So aij into vj. So it is taking j here because the number of columns is equal to number of rows. So for all the elements, it is for taking vj, and it is creating this intermediate key and value pair that is shuffled, reaching to a particular node where the reducer is there, and reducer will go through all the list of values and will perform the summation. Okay, so I think this is done. And by looking at this calculation, you have to write down the code. So in the exam, you all, whenever you have to write this question, it is for 10 marks. You show that how this matrix vector multiplication is happening, how the elements are stored, and then show the calculation, and then you write down this pseudo code. Okay. So we'll go to the next problem, and that is matrix multiplication using two steps. Okay. So this matrix multiplication can be done by using two different methods. It can be a one-step matrix multiplication, or it can be a two-step matrix multiplication. Okay. So here there are two matrices, matrix M and N, and I want to do the multiplication of two matrices. My first matrix is M, the second matrix is N. I'm saying that I'm going to use I and J variables to traverse the matrix M to indicate the element of M. So Mij is the element of small Mij is the element of matrix M, small Njk, and I'm going to use the variables J and K to indicate the elements of matrix N. Okay. I'll say that my resultant matrix is capital P, which is the multiplication of M and the elements of P are Pik, where I is the row and K is equal to the columns. Okay, so we can say that Pik element is equal to a particular Pik element is equal to. We are using three for loops in case of matrix multiplication, and the outer for loop is for all the elements. Now here we are concentrating on a particular element. So that outer for loop is not is to be not to be considered. So only two for loops. So in the two for loops for j is equal to 1 to all the columns, what we do is that we do the multiplication of mij into njk. We calculate this term and we go on adding it for all j's. Okay, so what we are doing is that we are multiplying mij into njk for all j times in the matrix multiplication to calculate a particular term. Okay, so here if you see it is 2 in first row and the first column so will be the first element. So 2 into 5 plus 3 into 2. Then first row and the second column. So it is 2 into 6 plus 3 into 4. First row and third column. It is 2 into 8 plus 3 into 7. Then 4 into 5 plus 9 into 2. 4 into 6 plus 9 into 4, and like this 2 by 3. So we could think matrix as a relation of three attributes. Like all these three matrices we have to, so like this you need to first study and observe. The matrix M will, the element of matrix M is stored as I comma j comma mij. Matrix of the element of matrix N is stored as j comma k comma njk. And the element of matrix P is stored as I comma k comma pik. This should be P. Okay. So, so have you understood this? I and J are the variables for matrix M. This J number of columns should be equal to number of rows of N. So that's why it is NJK, and the resultant matrix we get is of the type of IK, I number of rows and K number of columns. So that's why it is IK, PIK. Okay. So now in this matrix multiplication problem, I'm just showing this calculation on the top. First matrix is 2 by 2, second matrix is 2 by 3, and the third matrix is 2 by. So you get the answer as 2 by 3. This black color 2 by 3. Okay, so this is M into N. This is N into. Uh, this is M into N. This is N into. Suppose. So I'm. So 2 by 2 into 2 by 3, you get the resultant as 2 by 3. So now there is mapper one. In case of two-step matrix multiplication algorithm, in the step one you are having mapper and reducer, and again in the step two you are having mapper and reducer. So mapper and reducer task is executed in the sequence for 2 times. In one step multiplication, you are doing that everything in one step. Entire matrix multiplication calculation is done in one step, but two-step matrix multiplication algorithm is very convenient, and it's fast also. In case of two-step, the first step contains mapper and reducer, and step 2 also contains one mapper and reducer. So the mapper of first one output is given to shuffler, and then to reducer 1, and reducer 1 ka output is given as input to the mapper 2, and mapper 2 ka output is given to shuffler 2. Shuffler 2 ka output is given to reducer 2. Okay, so we are having mapper and reducer for 2 times in 2 different steps in this matrix multiplication. Okay, so here we are having a map function. So in the map function, you send the each matrix element to the mapper. So Mij for this Mij matrix with the key value pair, the element is. So what is the job of this mapper is that for every element of this matrix M or N, it is going to extract this intermediate key value pair, which is J comma the name of the matrix M, I, and Mij element. So Mij is the element, but I is written inside this as a part of value, and J is the key. Okay, because here this J is important here. So J is the key, and for that key we are writing what is I and the Mij element for the matrix M. Okay, so the mapper will create the output like this. That it will receive the element 2. How it will receive the element 2? In the form of 3 elements such as 1 comma 1 comma 2 for the matrix M. So it will get that input, and from that input it will generate the output as 1 comma the name of the matrix M, I is equal to 1, so J is equal to 1, I is equal to 1, and it is extracting the element M11, that is equal to 2. Okay. Now, like this, it will all the mappers will do. So for the second element is I'm taking this element now. The second row and the first column. Second row and first column is I is equal to 2 and J is equal to 1. So for I is equal to 2 and J is equal to 1, it is extract the element is M21, that is equal to 4. Okay, so this I'm just writing this to understand. Otherwise, it is going to store M comma 1 comma 2 and 1 comma M 1 2 as a value. So key is 1, value is M1 2. Key is 1, value is M2 4. Okay, so this is the second element. Now the third element is 3. Here it will store it as 2 comma M comma 1 comma M1 2. First row, second column. Then second row, second column. Okay, so this is about the matrix M. So for each matrix element for the M matrices, it has generated this output. This is intermediate key and value output. Now the second matrix is also given as input to the mappers. This that is also going to create the same thing. So j is extracted here, but here the j is equal to a row for the second matrix. So it is j is extracted here and k is inside as a part of value. So the element is suppose 5. So 5 means 1 comma 1 comma 5 is the input to the mapper. 1 comma 1 comma 5 is the input where j is equal to 1 and k is equal to 1. So it will create the output as uh, j should be extracted as 1 n11 is 5 and j is equal to 1 and k is equal to 1, so it will write it 1 comma n comma 1 comma, so n comma 1 comma 5 will be the value. For the second element is n12 is equal to 6, so j is equal to 1 and k is equal to 2, so it is written like this. So it will create this intermediate value, and this is key for the second element. For the third element is n13, so it will be extracted like this. Then the fourth element is n21, uh, fifth element is n22, and sixth element is n23. Okay, so just understand this, like the element is given as input to the mapper, and the mapper is going to extract or create the intermediate key value pair. For the matrix n, it is going to create this key value pair where j is extracted, like if the element is 4. So element is 4 means it is n22 element. So j is equal to 2 and k is equal to 2. So j is extracted and it written down as a key, and this k is inside the value. And value is combination of three elements where it indicates the matrix name and the k value and the actual value of the element. And for matrix M, here it is ulta, like j is outside and I indicates row. So row is inside for matrix M and column is outside. Here row is outside, row ka iterator is outside and column ka iterator is inside. That is only the difference between M and N. Okay, so have you understood what is this mapper is doing? It is taking a particular element of the matrix I comma j comma then the element and the name of the matrix, and then it is creating the intermediate key and value pair. Now shuffler will start working. Okay, so this is the mapper's output intermediate key value pair. Shuffler will start working. What shuffler will do is that same keys will be shuffled at one reducer. Okay, so now here see this output. Here the key is 1 and 2. So there are two types of keys, 1 and 2. So all the keys are shuffled and they are reaching to a reducer. So here in the black color I am showing the output of the shuffler is the key and list of values. So this is the list of value. All this list, all these values will go to the reducer and reduce. This is input to the reducer of step one. This is the logic of this reducer. What reducer will do, that if it is a value coming from M, and it will see the corresponding value for N, and it is going to produce a tuple or a record where it is going to write I comma k comma mij into njk, and it is paired with the value j. Okay, so the output is key j paired with this list of values. So what is the meaning of this is that this is the input that is returned going to the reducer. Reducer will see what is M. So the first element is from M. So what it will do is that for the first element, it is trying to find out the corresponding n ka elements. And for the first element, it will do the multiplication 2 into 5. And it is going to write I and k. Okay, so this is your I. And this one is the I and this one is the k for n. So it is going to create a pair 1 comma 1 comma 2 into 5. Then it will go to the second element and it is going to create the pair as 1 comma 2 comma 2 into 6. Then the first MK element will go to the third MK element and it is creating the output as 1 comma 3 comma 2 into 8. Okay, so that's what we will see here, that it is going to create this particular list, this particular values, like for j, j is equal to 1. This is the key j. So this j is equal to 1. It is creating 1 comma 1 comma 2 into 5, then 1 comma 2 into 2 into 6, then 1 comma 3 into 2 into 8. Like this, it has created all j's, and then it will take the second element of m and will repeat the process. So for this, it is going to prepare 2 comma 1 comma 4 into 5, 2 comma 2 into 4 into 6, 2 comma 3 into 4 into 6, like this. Okay. So any doubt in this? Similarly, for the key 2, for the second key, all the uh, keys with value 2 are shuffled by the shuffler, and they are reaching to a reducer. Reducer is going to take the first term of m and it's going to multiply it with all n terms and is going to produce the output as a key as I comma k comma mij into njk. So it will produce here uh, this first term, and it will append j to it as a key. So intermediate key is 2. So it is 1 into 1 into 3 into 2, 1 into 2 into 3 into 4. Like this, it will create the output. Okay. So, so this is the first step of two-step matrix multiplication. But I think now the time is over. So we'll have there are 5-6 minutes are remaining. So we'll have the revision of the step one of the matrix multiplication, and tomorrow's lecture I'll do it again. Okay. So what we do in the two-step matrix multiplication is that there is a mapper function. There is a mapper function. Mapper function will receive the element. Mapper function is going to receive the element 2 as 1 comma 1 comma 2. For that for that element, it is going to extract the intermediate pair as j is outside. So 1 is outside, row is inside, row iterator is inside, m comma 1 comma 2. So for the element 2 1, it is going to create the pair as 1 comma 2 comma 4. Like this, it is going to create the intermediate key and value pair for m and n. Only the difference is that here the column iterator is outside, here the row iterator is outside for n and m. And it will generate this intermediate key value pair. That intermediate key value pairs are shuffled by the shuffler, and shuffler will receive, this is the output of the shuffler, where it will get all the keys with value 1, and all the values are combined together in the list, and this list is acting going as input to the reducer. This reducer will what it will do, this is the algorithm pseudocode which you have to write in the exam. The pseudocode says that for every key j, it will examine its list of associated values, and for each value that is coming from m comma I comma mij, and every value that is coming from n comma k comma njk, it will produce a tuple I comma k mij into njk. So this is done for the every value. So this is going to produce the output as 1 comma 1 comma 2 into 5, 1 comma 2 into 6, 1 comma 3, and then 2 into 1, 2 and 1, 2 2 and 2 3, a multiplication, and it is joined with j, and this is the output of the reducer for the step 1. Okay, so now we will stop here. Okay, so what I will do tomorrow's lecture, I may ask you some questions. So you go through the previous lecture and today's lecture about MapReduce.
Okay, ma'am.
Yeah. So we'll see you tomorrow morning. And tomorrow you read that MapReduce ka theory part and today's lecture. Today's lecture